Hi guys, this is Devina Dhuri and my teammates Saved and Tejas, and we are here to present detection and prevention of forest fires. So as we know that the Amazon has been burning for weeks and months together. The mainly concerns is 75,000 of wildfires every year, 7 lakhs of acres of land getting burned, and a risk to vegetation, wildlife, and thus humans. To combat this, we propose a solution using sensors. We use the sensors to detect the fire. Then, based on that detection, we predict the possible areas of the fire which could spread. And finally, we try to contain the fire. So basically, our entire architecture goes through like we have an analog sensor, there's a TMP36, and we have three DHT11 digital sensors. We have a node MCU, ESP8266. All of these sensors track all the temperature using the 8266 and then finally communicate it to the main PC hub where it's used for prediction, simulation and containment. So basically this was the setup. As we can see first, this we used to denote our sensors, the 4 sensors. This was our main area to depict a forest. We kind of added certain material to make it more like to catch fire. We added few trees and few animals, and this is the final setup to make it look like a forest. As you can see, these blue 3 ones are our DHT11 and this tiny one at the back is our analog sensor. So finally coming up to our demo. So let me just show you the demo. So as you see over here, we've just put this a little area on fire. This is the Unity application where there's nothing happening, the console based application and our sensor readings. Everything is 0 for now. So as we move forward, let me just move a little ahead. There. So as we see, the 15 sensor, that is this analog sensor right here, has detected the presence of fire. As soon as it's detected the presence of fire, immediately we could see that the Unity application and the console-based application also detect that there's fire and they start the spread. Now this spread is a prediction, whereas the spread is the actual spread. So as we move forward, we can see that the spread's increasing. This one over here, the little tiny red one, is a prediction. This one, green one, is also a prediction that that's going to be the next area. Whereas you can see in the temperature, we still have no records for 21. That is the sensor. But yet, our algorithm has predicted that that's going to be the next area. So while moving forward, we see that 21 has turned to 1. Now let me tell you the difference between 1 and 2. 1 basically means that the sensors are sensing heat, whereas 2 it means that there's actually a presence of fire. We've just used this case in case that the temperature actually increases but there's no permanent heat anywhere. So if we move forward, so as we can see, 1 is 7, 21 is 1, 16 is 1, 15 is 2. That is, at the 15th area there is a lot of fire, whereas for 16 and 22, it's just like detecting that there is presence of heat around. You can see here that the 15 is set on fire, 16 and 21 are the ones predicted, as well over here, they are predicted. So as we come near to the end, we can see that finally 21 has detected the presence of fire. So you can see the fire has reached this area. Whereas over here 21 has also detected the presence of fire. Whereas 16 is still as a prediction. So let me just go to the end of this. So as you can see, 21, 2, 16, 2 and 15, 2. These three denote that these three areas have already been on fire. Whereas over here, same thing, 16, 15 and 21 have been detected that they have been caught on fire. Whereas if you see in Unity, though there was a prediction, the fire really didn't spread. So you can see the actual spread, whereas over here there's hardly any spread. That means that we've used this containment algorithm to actually reduce the fire. So coming back to the presentation. So this was the aftermath, how it actually looked after everything was burnt. You can see that we have deceased animals, we have the entire thing burnt, like almost 4/5 of it is burnt. This area is actually the destroyed forest bed, whereas this area, even though it looks green, due to the soot and ash and debris, it cannot be really used for any cultivation anymore. So they're basically coming up to the algorithm that we use for prediction. We use boundary detection and lane detection. So boundary detection basically detected all the possible sensors when a particular sensor is being triggered, whereas lane detection only detected those ones which after the line was crossed, it would detect that kind of sensor. So since we say that the boundary detection detected way more sensors that were actually triggered, the accuracy is really low, like about 35 to 40%, whereas lane detection had a really high accuracy, about maintaining from 80 to 90%, since it was nearly precise towards the prediction. So based on all this, as we see that what if we had used this algorithm for the actual Amazon forest fire or any other forest fire that's happened across the world, we could have saved millions of money, a lot of trees, animals, and human life too. So here's an analysis that we put forth. These are the number of sensors and node MCUs we would need, given 3,500 square mile of area. And this is the cost, considering both the sensors, the ESP, and extra wiring cost. Based on that, if the spread was slow or fast, this would be how much area was saved. The government proposed $22 million to combat this, but if we use this algorithm, we could save nearly $13 million to $10 million based on the speed of the fire. So I would just like to come back to the challenges that we faced. As you see, we used four different sensors. We used 3 DHT and 1 analog sensor. The reason for that was the DHT sensor cannot really measure temperatures greater than about 90-9500 Fahrenheit. That's why we use an analog, which, as you've seen in the video, the demo, it actually recorded up to 400. And then the second one was, you might be thinking, why did we use a console-based and a Unity-based application? So basically, the Unity-based application, as you've seen, was basically show how we could contain the fire, which was a little more tedious on the console-based, whereas because we have used so much of containment and processing power and considering the number of objects, Unity will really lag if you use so many sensors. So the console based was basically used to show that given such a huge number of sensors, how would the entire process look like? And the analysis, this video that you just seen, was basically drawn out from the console based application. That's it for today.